Unfortunately, my slides are really centered because I had to change the resolution. I hope this works out. And it's about protecting your privacy with FreeBSD and Tor. And with privacy, what I mean here is mostly anonymity. But there are some other aspects that I'll talk about later. So I want to first talk about who needs anonymity anyway. It's just for criminals or some other bad guys, right? After that, anonymization concepts, then Tor. Tor is it's a tool to anonymize you on the web. Then I talk about what FreeBSD has to do with it, and what else you have to take care of when you want to be anonymous on the web or on the internet. And if time permits, I'd like to do a little demonstration. Okay, so who needs anonymity anyway? Anonymity has a pretty bad ring to it to most people. But it's really important for journalists. There was a case in Thailand last year when the military coup was going on. And journalists in Thailand couldn't really... do I have to hold it like this? Okay. Journalists couldn't really get the information they needed to do their work. Also, informants, whistleblowers, people who want to tell you about corruption going on in government or in companies and don't want to lose their job about it. Dissidents, best case when in Myanmar a couple of weeks ago, when when all the Buddhist monks were going on the streets and the internet was heavily censored. And it was really dangerous to do anything on the internet. There's also socially sensitive information, like when you want to, when you were abused and want to talk to other people about it, but you don't, naturally you don't want other people to know who you are, because it would be very embarrassing. Also law enforcement, for example, when you want to set up an anonymous tip line for crime reporting, and also companies that want to research competition. There's one case that a company wanted to check out the website of the competition, and they noticed when they used Tor that they were actually getting a different website when they were coming from their corporate LAN than anyone else was getting. So it's a good way to check out competition like that. Also military. Actually, the military is one of the original driving forces behind the anonymization research. And maybe you may have heard of the European Union Data Retention Directive, where connection data gets stored 6 to 24 months. It depends on the actual implementation in the different nations. 2 weeks back, it was the law was passed in Germany. So from 1st January on, every connection, phone connection, SMS, IP connections, email, or the dial-in data needs to be stored by the providers for 6 months. And sooner or later, it's going to be in Poland as well. Well, you're part of the European Union now, so welcome. Okay, and maybe you want to hide what interests do you have and who you talk to. I mean, like all of you know, the internet isn't very secure and anonymous in the first place, so your ISP can actually see who you're talking to, if they bother to find out. Yeah, and also criminals, but they already do illegal stuff, and they don't care about doing more illegal stuff to stay anonymous, right? They can steal people's identity, they can rent botnets or create them in the first place, and or just crack one of the thousands of Windows computers online. It's no big deal. So criminals already do this, and the normal citizens can't do this. So Yeah. So all the groups that need anonymization are very different, but they all have the same goal. And this is also one of the key concepts of anonymization. You can't really stay anonymous on your own. You need the help of more people. And the more diverse the group is that needs anonymity, the better. Okay, so I want to talk about two anonymization concepts. Proxy. Everyone here probably knows how proxy works. Clients connect to the proxy and request some website or whatever, and the proxy just passes it on and passes the reply back on. Proxies are fast and simple, but it's really a single point of failure. Like when law enforcement or anyone else wants to know who you're talking to, they just get a subpoena or break into the computer room or whatever. It's pretty easy. Second anonymization concept is mix. It's really old, from 1981. So you can see how long the research in this area is going on. The mix is kind of similar to a proxy, like clients connect to it, send their messages, and the mix collects them, normalizes them, like it puts them all into a common size, and as you can see here, it shuffles them. So it waits until it has enough data in it, and just shuffles them and sends them back out. So this is to protect against correlation attacks. But as you can, and when you actually put several mixes behind them, it's a mixed cascade. And between mixes, there's also encryption going on. The first, as a client, which is, you could see here if the slide were presented. Alice gets the public keys of all the mixes and encrypts the message with each of them. And each mix removes one encryption layer, and the last one actually passes on the message unencrypted. And reply path is the same. So, as you can probably imagine, if you wait until you have enough messages, and all the public key encryption is going to be pretty slow. And this concept is mostly used for remailers, like Mixminion, for example, where it's not really important if the message is a couple of seconds late or something, but it's not really great for low latency connections, like web browsing, for example. But what's good about it is it's distributed trust. Just one of these mixes has to be secure to actually anonymize the whole connection. So it's slow, but it's distributed trust, which is good. So I want to introduce Tor. Tor stands for the Onion Router. It's a concept that's actually builds on both of these concepts, mixes and proxies. It's a TCP overlay network. That means you can tunnel any TCP connection through it, theoretically. Theoretically, I will explain a couple of slides later. It provides a SOX interface, so you don't need any special application proxies. Like any application that uses SOX interface can just talk to Tor. And it's available on all major platforms. And what's especially important that it's available in Windows, because, like I said earlier, you want a really diverse group of users. So you actually need the normal user, not just geeks. Well, it aims to combine the positive attributes of proxies and mixes. Like proxies are fast, but sync point of failure. And mixes, distributed trust, you want to combine them. So Tor uses not only public key encryption, but also session keys, so symmetric key encryption. So all the connection setup is public key, so you get well, authentication and stuff. And the actual communication that's going on later is always symmetric key encryption. And it's also TCP multiplexing, so you can run several TCP connections through one virtual Tor connection. And the design goals, deployability. Like, you don't want the user to actually have to patch the TCP stack of the operating system or something. It has to be in a workable state really fast. Usability, so you get the normal users, not just some geeks. Flexibility, it's aimed to enable more research in this whole area. So the protocol that Tor uses should be really flexible. And of course, simplicity, it's a security application, and well, complexity doesn't play well with security. So this is how Tor works, more or less. Dave is a directory server. It caches information about the network state and which Tor servers are available in the network. And Alice downloads this whole list from Dave. You see the Tor nodes with a plus here. And it just chooses 3 random of these servers when she wants to talk to Jane, for example. The first one is the entry node, middleman node, and exit node. I will use these terms later. So this Alice talks to the entry node. There's a connection request going on, and it's public key encrypted. And they establish a session key. And the same thing goes on between these two and these two. So they can communicate later on. And what's really important, the last connection here is actually unencrypted. I will talk about it later. So it has to be unencrypted so you can actually get your request through. This is a virtual circuit that gets established, and every 10 minutes a new circuit is built when a new website, when a new request comes through. So this one stays, well, this connection to Bob stays in this circuit, and when after 10 minutes Alice wants to talk to Jane, a new circuit is built. And this is important to get strong anonymity in case one connection is compromised, for example. So these 10 minutes are really an arbitrary value. You could choose anything, but you actually have to do the research which value is best, and 10 minutes is compromised. With Tor, you get exit policies. This is important for the exit node, the one which actually sends the original request to the destination server. And you can control which TCP connections you want to allow from your own node, if you want one. Has a default policy, which blocks SMTP and NMTP to prevent spamming and all this stuff. But you can actually allow SMTP if you want. And there's some other ports blocked. But the rest actually works. So HTTP, SSH, all the important stuff that you would want anonymized just works. And if you this is important for if you want to run your own node. What kind of node you actually want to run. If you look at the picture earlier, there's this 3 different nodes: entry node, middleman node, and exit node. And which node you want to run depends on how many problems you want afterwards. I will talk about it later. As this one, the exit node actually forwards the request to Jane. It depends upon what the user actually does. If the user, Alice in this case, insults someone in the web forum, then the administrator of the forum will see the IP address of the exit node in his logs, and not the ones for Alice. So he's going to have the problems later on. So I will talk about it later. But you have to keep this in mind. And if you block everything, then you can play the role of entry node or middleman node, which is also important. Special feature of Tor are hidden services. So services which can be accessed without having an IP address of them. So you can't really find them physically. So if you want to run a hidden service, you can do it from anywhere. You can even do it from inside this private network here. You can set up a service and everyone in the outside world can actually access it, even if you don't have the rights to do ports forwarding or something. This is really important to resist denial of service, for example, because every client that wants to access this service gets a different route through the network, and it's hard to actually DOS it. And it's also important to resist censorship. And the addresses look like this. It's really a hash over a public key, and each hidden service is actually identified by a public key. This is how it works. You have Alice, the client, and the hidden server Bob. And if Bob wants to set up a service, he chooses 3 introduction points out of the whole mass of Tor servers. And it also has this public key to identify a service. And he sends this public key and the list of 3 introduction points to the directory server. Now, if Alice wants to connect to Bob, the first thing she does is download this list with the introduction points and the public key from the directory server. After that, she chooses one of the introduction points and posts a so-called rendezvous cookie there. It's just a piece of data, so she can identify herself. And she also gives the introduction point the address of a random rendezvous point that Alice has chosen. So what happens then is Bob notices that some data has been stored on the introduction point, and Alice and Bob connect to the rendezvous point. And Bob uses this rendezvous cookie to actually identify himself on the rendezvous point. And after that, all the connection of the data runs through this rendezvous point. If time permits, I'll actually set up a rendezvous hidden service here, so you can actually see how it works. I'll also demonstrate Tor, like I said. There are some legal issues to be recognized. As you can imagine, Tor may be forbidden in some countries, especially totalitarian countries which censor the internet anyway, and you may get into trouble for using Tor. Actually, anyone notices. There can be crypto restrictions. For example, in Great Britain, the Brüffer Act. I'm not really sure what it stands for. But it basically says that if the government wants, then you have to give up your crypto keys so they can decrypt your data. And yeah, it's not really great. And it's actually, last week was the first case where this was actually used in Great Britain. There may be special laws, like in Germany, the so-called hacker paragraph. It's just a nickname, it has some cryptic legal name in reality. And it says that you're liable if you give people access to tools that they can use to to do illegal stuff, more or less. It's really not concrete, and no one really. Well, it could restrict anything from Nmap to God knows what network tools. And it was actually passed, and no one really knows what is really restricted by it. So Tor could be restricted by it, because you could enable people to do illegal stuff, but no one really knows. And the biggest problem is that when a connection gets sent through the Tor network, the IP address that gets sent, that the destination server actually sees, is one of the exit node. So when a client actually causes trouble, then the one who gets into trouble is the exit node provider. And so stuff that gets done through the Tor network is like sending ransom mails or distributing illegal stuff, and this all happens. And if you're unlucky as an exit node operator, your server gets seized or something. And there's random stuff that can happen. So as the exit node provider, you can get letters from law enforcement agencies, and yeah, what are you doing there? You did some illegal stuff, and you have to explain to them that you're providing a Tor server and it wasn't you and stuff. And for example, the FBI in America actually knows what you're talking about when you tell them that you're using Tor, so they won't bother. But in Germany, the law enforcement agencies are actually so-so. It depends on what kind of guy you're actually talking to. So, what kind of role plays FreeBSD here? FreeBSD is really well suited as a Tor node. When you're operating a client, so you just want to use the network, it doesn't matter what kind of system you use, and it shouldn't matter. This is one of the, like I explained earlier, one of the design criteria of Tor. So it doesn't matter if you're using Windows or FreeBSD. But if you're using Tor, it's actually the security of others depends on your node. And when you're operating a node, it's important to have operational security. And jails are really great for this. So you can run a Tor server in a jail. There's also disk and swap encryption, which is important, especially the swap encryption. And there's also audit and the Mac framework when you want to harden your installation. And what's also nice, Tor servers do a lot of public key encryption, and this is pretty slow. So it's great to have hardware acceleration for this. And probably the biggest feature are well-maintained Tor-related ports. There's the main port, security Tor, which is the client and server if you want to run a network node or just a client. There's Tor Devil, and these are really up to date. Tor development happens really fast, and the ports get updated pretty soon after a release is made. There's FreeBSD, which is an web proxy, and we'll use it later when during the demonstration. And there's Net Management Vidalia, which is a graphical front end, also for Windows. And there's Transproxy Tor, which enables you to actually. Well, there's some badly written applications out there that do stuff that makes it hard for Tor to anonymize them. And you can use Transproxy Tor to tunnel such connections to the Tor network. We'll actually talk about that on the next slide. Yeah, what else do you need to take care of besides running Tor? There's name resolution. Some applications just bypass a configured proxy. For example, Firefox versions below version 1.5 would send all data through the proxy, but not DNS requests. So they would actually resolve them themselves. And so your connection is actually anonymized, but the DNS server really knows who you were talking to. And that's not really the intention of it all. But newer version is actually fixed. There's the usual cookies, web bugs, Brüffer, and stuff, which sites can use to track which websites you're visiting. And it's just the usual disabling stuff. And FreeBSD is a great tool to normalize HTTP traffic. Oh, no, so it's also great to filter out advertising stuff. This should be really obvious, but apparently it's not. There are so many people who don't realize that the last connection in the chain is actually unencrypted if you're not using a secure protocol. So people actually get their mail through POP3 or something, and the exit nodes can just run dsniff and sniff out all the passwords. And it's really surprising how many people do this. Yeah, so lesson learned, use secure protocols. Well, there's also services that require registration. For example, with your email address or personal data. And if you're using Tor and you actually log on to one of those services, Tor can help you. So, I want to actually demonstrate how this all works. I have installed Tor and FreeBSD on this system. Config files are in the usual places. And you have to read this. It's a little small. Is this all right? Yeah. Okay, great. So there's this Tor.rc sample file, which we can use now. So there's the usual comments and stuff, and there's much stuff that we don't need for the moment. There's this socks port and socks listen address information. It just tells you where to connect your proxy to. So this is the information we use in FreeBSD to access Tor. All we have to do to actually use Tor is copy over the config file. We can just start the service. So it tells us it's running. Now we have to take a look at FreeBSD. There's also lots of stuff that we don't need right now. What we need is we need to tell FreeBSD where to send connection requests. Where is it? Okay, I've actually entered this earlier. All it says is forward all requests to the Tor server via SocksY. So we just started. Oh, it's already running. Okay, so we're all set. Now we can just do everything with our browser. Well, startup time sucks a bit because of my external drive. Okay, proxy settings. We just put in our FreeBSD server, which listens on port 3128, hopefully. Or does it? Oh, 8118, okay. Okay, so every connection we want to make should actually be routed through the Tor network. This is going to take a little bit because all the route selection needs to be done, all the public crypto, and there's also network latency. Hopefully this will work now. Once the connection is actually set up, it's pretty fast, not like this. And it's all really dependent upon which kind of nodes you get. If you have a node that's run on a modem, then you have a problem. It's really slow. Okay, while we're waiting, you can actually help. While we're waiting, we can actually take a look how our hidden service is configured. There are some lines further down the config file that are about hidden services. Okay, So you can see here hidden service peer and hidden service port. As I said, a hidden service is identified by a public key. And if you uncomment this stuff and restart Tor, it will actually generate a public key and put it into this directory. And it will, well, it actually says to, that we had this onion address earlier, and it will just route every connection to this address to this localhost line. Okay, what's going on here? This could be the case that that an exit node doesn't allow DNS requests. Okay, this is typical when you want to show stuff, it doesn't work. It worked earlier, so it's not the network's fault. But back to the hidden services. So we actually need to change this. The default directory in FreeBSD is vardb tor for all this stuff. And when we restart Tor, it will actually create this service directory by himself. There's also a web server listening on port 80 on localhost, so we should hopefully be able to see this later on. Okay, so let's see if the stuff was already actually created. Okay, so you have two paths in this directory, hostname and private key. Private key is self-explanatory. And the hostname is actually what you give to people if you want to publish your service. So let's copy this. This is actually less likely to work right now because it takes some time for Tor to choose the introduction points, send all the stuff to the directory service. It takes time for the directory service to sync up and actually distribute the information to the clients. And when we want to exit the service, we actually put this address into the address line. And Tor knows how to deal with this .onion top level domain. So this usually actually works. Let's see what's going on here. Well, like I said, this one will take a while, and what's going on with the other one, I can't actually say. But usually you can just go to one of these service websites that tell you your IP address. And well, Google is a better example. You can go to Google, and Google will get you a localized web page. For example, when you're from Germany and you go to google.com, you get a German web page. And if you're using Tor, and go to Google, it depends upon where your exit point is located. For example, if it is in the Netherlands, you get a Dutch Google, which is pretty cool. So I'll have to take a look later why it isn't working. So let's just continue for the moment. Okay, to summarize, Tor is actually useful if you want to be hidden on the net, if it actually works, not in this case. It's also pretty cool to offer services from anywhere. So theoretically, it should work that I publish my hidden servers that I run here, and anyone in the world that's connected to the Tor network can actually access it. And FreeBSD is a pretty cool platform for Tor because it's performant. It has very nice security features like jail, and yeah, if you want to run a Tor node. And tools like Tor are really needed in our times. If you look at the data retention initiative, this isn't going to get better anytime soon. So we better create the tools now to circumvent it. Take a quick look at the browser again. Apparently the connection setup failed, which I can't do anything about right now. Huh?
One question.
Yes.
Which port is using?
Which one?
Why was it? Because here in this return we have blocked higher ports, so we can't use.
Oh, that's what you mean.
So it shouldn't work.
It depends upon. Well, you can use any port you like. It depends on what port the nodes use, and nodes can use any port. For example, when I want to run a node, I can put it on port 80 if I want. So anyone who has HTTP access can actually access my node. So yeah, in theory, you can use any node, any port you like. So this isn't going to work. Maybe I'll just, if anyone's interested, I'll just try again later.
But first it connects to the directory server, right?
Huh?
But first it connects to the directory server to obtain the list of
Right.
accounts. So which port directory server is?
That's port 80. It's a usual HTTP connection. So are there any other questions?
Yes.
Yes.
I think your DNS requests were unencrypted and sent directly to DNS server. Because I'm almost sure you have to enable in Firefox to use source proxy to send your DNS request.
Oh, really?
Yeah.
Okay. Well, usually I use Opera, so I didn't know. Yes?
Is the global network of Tor nodes available? Is it one directory server that serves all this information on all these available nodes, or are there different
Yes.
sites for those nodes?
There are about 300, I think about 300 Tor servers around the world.
Is it only just one directory server for all?
No, it's alright, right. Should mention that. At the moment, there are 3 directory servers worldwide, and you can recognize them by their public key. And the public keys are hard-coded into the source code at the moment. So the Tor developers actually run those directory servers. But this is really critical critical infrastructure.
Do you have any statistics on average known traffic or something?
Well, it's hard to say because the question was whether there are any estimates on net usage and all this stuff. It's really hard to say because it's an anonymization network, so you can't say for sure, but there are estimates that there are 10,000 to 100,000 users around the world, and I'm not sure what the traffic. I used to run a middleman node, and in 1 month it would it was on a 100 Mbit dedicated line, and it made about 1 terabyte of traffic. So it's a lot of traffic going on, and unfortunately also a lot of file sharing and this stuff, which doesn't really make sense because it's very slow. So Tor is really cool for web browsing and stuff, but if you really want to move a lot of data, it's not a good tool. Any other questions? Doesn't seem to be the case. Okay. Thank you very much.